Okay, so here's lesson 1.2. We're going to start to talk about angles and the unit circle. The beginning of the lesson has some vocabulary for you to read through here, and we'll talk a little bit about what that looks like in the pictures to the right. All right, so first of all, this would be an angle in standard position. Standard position just means that that angle starts at the positive x-axis, okay? So we would call this standard position. There's parts of an angle that you need to be aware of. The first is called the initial side. So anytime that initial side is on the positive x-axis, that would mean it is in standard position. All right, the angle we're actually talking about here is theta, and that would be how far the arm or the terminal side is swinging in this particular picture. So we would call this the terminal side. Let's remember what terminal means. Terminal means end. Okay, so when that leads us straight to our next definition, which is coterminal angles, which would be two angles that end at the same place or have the same terminal side. So in this particular picture, we have that angle theta. All right, we could also have an angle that starts at the same initial side as that one and swings all the way around, all right, to end with the same terminal side. This would be a negative angle, all right, so it would be some form of negative theta, all right, it would actually end up being negative 360, okay, minus theta, but we'll talk more about that in a minute, okay. The unit circle is also something we're going to talk about, okay, and basically the unit circle, all right, is this idea that we have a circle that has a radius of 1. So if you imagine this circle, all right, lying over top of a coordinate plane. So I'm going to draw a coordinate plane in here, right? Okay. All right, and here's our x and y axis. I'm going to highlight those in a different color. I'm going to make those red. So that's my y-axis. This is my x-axis. Okay, so again, we talked the other day about how trig is the collision of geometry and algebra. And here is one of our first experiences with that. So if this is the x-axis, this is the y-axis, the purple lines are, this is a super zoomed in coordinate plane, right? I could zoom out, but we're just zoomed in super close. Okay, and that unit circle fits inside, okay, of that smallest section of the coordinate plane, which will be bounded by 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so everything that happens inside that circle, all right, is bounded by those coordinates because the radius of the circle is 1, which means all these values along this circle here are going to be values that are less than 1. Okay, every value around this circle, okay, except that it's for furthest points are going to be values smaller than 1 with respect to the coordinate plane. Okay. All right, let's talk a little bit about angles. Okay, so a positive angle always has a counterclockwise rotation. All right, so if that angle starts at the positive x-axis and is going counterclockwise, it is going to be a positive theta. Now, I would not call this angle 45 degrees. That 45 is simply given as a reference for you to be able to find the actual angle, all right, which would be this angle right here. All right, how far is the arm swinging? So we're going to try to use some ideas, all right, about what we know about circles, okay, to determine that. All right, in other words, we know that this is 90 degrees. We know that this is 180 degrees. This is all geometry facts. We know that this is 270, and we know that this is 360. All right, so because this terminal side is in the second quadrant, we're going to use 180 as our reference. We're going to subtract away that 45-degree mark that they told us about. So if we have 180, okay, and we're going to minus 45, that tells us that our angle theta is 135 degrees. When you draw angles for me in this class, I'm going to actually have you label both parts of that. So if you're trying to draw 135 for me, I want to see the 135, and I want to see some other reference for it. Again, just to get that extra practice. A counterclockwise rotation would be a negative angle, so negative theta. Okay. Again, they're just giving us a reference here. That's not the actual angle. The angle is this how far this arm swung the entire way from the initial side. Okay, but we need to use some other facts about this particular area of the graph to find out what the whole angle is, and we know that this is 90 degrees. Okay, so 90 plus 30 gives us 120, but then we know that this is a negative theta because it's going clockwise. So negative 120 degrees would be that whole angle. Okay. All right, so here's some of those places we should know about. 1/4 of a circle is 90 degrees. 1/2 of a circle is 180 degrees. All right, and 3/4 of a circle is 270 degrees. All right, and again, those are sort of the reference points that we'll use to find other angles, okay, in whatever particular pictures we're talking about. And here's our first couple tries at that. Okay, so if I'm trying to label 85 degrees, this is what I was talking about a minute ago. I want you to label that, and I want 2 labels on it, okay? Yeah, maybe a little overkill, but I think it's good practice for us. So 85 degrees is going to be a first quadrant, and again, I'm going to keep using Alg 1 lingo here, okay, because we'll use that a lot. A first quadrant angle. So I would say 85 degrees is right about there. Okay, I want to label that angle 85 degrees, and then I want you to label it somewhere else. Okay, so I'm going to label this as 5 degrees. Okay, is that required for me? Yes. Is it required in real life? No. Okay, so that's our first one there, 85 degrees. All right. Negative 320 degrees. Okay, so this is challenging, right? Because we're going clockwise now, so the negative direction. All right, and how far are we really going to go with that? Okay, well, there's 90. Okay, there's 180. There's 270. All right, so 320 is actually going to be, again, a first quadrant angle. Okay, we're just rotating the opposite direction. How far into the first quadrant? Okay, well, if we know that this is 270 right here, okay, and it looks like it's going to be 50 more, so it's over halfway into the first quadrant. So I would draw this angle, and again, this is required. You need to draw that little squiggly line to show that it is a negative angle. All right, I'm going to label it as 320 degrees, okay, as the whole angle. But then I want you to label some other part, okay? You have some options here. Some people might say, oh, okay, well, this is 50 degrees past 270, so I'm just going to label that as 50. Some people might say, okay, well, how much is left? There's 40 degrees left to 360, so I'm just going to label this 40 degrees. I don't particularly care. I would just like to see both labels. All right, 210, that's a positive angle. All right, so keep in mind here, we're going to go 90, we're going to go 180. All right, and then 210 is going to be somewhere in the third quadrant. This is a third quadrant angle measure. All right, so I'm going to draw, all right, my 210, okay, as the whole angle. But then again, I want you to label that some other way. All right, some people might say, oh, okay, well, that's 30 past 180, so I'm just going to put a little 30 in there. And that works great. Last, I have negative 135. All right, again, I'm going this direction now, right, because it's negative, so negative 90. And I'm not going to get to 180, which means I'm going to be, again, in the third quadrant angle. Okay, so I can label that as negative 135 as the whole angle. But then I'd still like you to label some other familiar part, all right, or some other reference from that. You can do a couple options here, right? So remember that this will be 90 here, okay? So I could just label this as 45, all right? If I take 90 away from that 135, all right? But any other part of that that lets me know, okay, what that angle is going to be, I think is good practice for us to start to do. Next, we have this idea of coterminal angles, okay? So we're going to look at some coterminal angles here. This is asking us to sketch 135 and negative 225 on the same coordinate grid here. So I'm going to go 135, that's a second quadrant angle. All right, and it's about halfway through the second quadrant, 135 degrees. Okay, then negative 225, I got to go the opposite direction. Okay, I'm negative 90, negative 180. Oh, and then 45 more. I actually end up at the same place. Okay, so negative 225. All right, and 135, we would call those coterminal angles. All right, now how would I go about finding that? That's sort of the more important part, okay? And that's what we get into for these next two problems. If I have some random angle, like 198, and I want coterminal angles, it's real simple. I either add 360 to that coterminal angle to find that coterminal angle, or I subtract 360. Again, all we're talking about here is one revolution around the circle, and every time we make that revolution, we get a new answer. So if I added 360 here, I will get 558. If I subtracted 360, I will get negative 162. Okay, so now I have three angles that are coterminal with each other, right? I have the 198, I have the 558, I have the negative 162. I could find more, right? How could I find more? Well, I'll just add 360 again, all right, or subtract 360 again, and I can do that forever and continue to find coterminal angles. The point that we're making here is that every time, all right, that arm swings and gets 198 degrees, so right there is 198, all right, but every time we swing that arm, okay, every time ends up being a coterminal angle. All right, we can swing it forever. All right, our angles with measures of 40 and 680 coterminal, how do we determine that? Well, the simple way, all right, is to just take 40 degrees and add 360 to it. And that gives us 400 degrees. Okay, well then I would want to add 360 again. Okay, and when I do that, I get 760. So I went right past 680. I did not get 680 for an answer, therefore they are not coterminal. I could have done the same thing by subtracting 360 from 680, okay, until I get past 40. All right, we're going to keep chugging along here. We have some more talk about the unit circle. The unit circle actually relates directly to your special right triangles from geometry. This is a 30, 60, 90. You had side ratios with those right triangles, whether you remember or not. All right, we always determine the hypotenuse is 1 here because the unit circle has a radius of 1. The side across from the 30 is always half of the hypotenuse. All right, and the side across from the 60 is always the square root of 3 times that previous side. So square root of 3 times a half is root 3 over 2. And these are ratios for special right triangles from geometry class. Okay, so again, reiterating that point that this is the collision of geometry and algebra 1, all right, for the most part. So our 45-90 also had side ratios that were consistent. They were always half the hypotenuse multiplied by root 2, okay? And then we just take those triangles and we overlay them into that unit circle that we were talking about earlier, okay? So this right here would be your 30-60, okay? And if we labeled the sides of this triangle the way we learned them in geometry, we would say that this side is root 3 over 2. We would say that this side is 1/2. If we take that one step further and we talk about algebra 1, we know that this would be considered the x side and that this would be considered the y side. So we're basically using the idea of special right triangles from geometry, intertwining that with what we know about algebra 1 and coordinate plane to come up with coordinates, okay, for each angle around the unit circle. Okay, so the 30-degree angle in the unit circle, okay, is represented by the two coordinates, x and y, root 3 over 2 and 1/2. All right, the 45-degree, okay, coordinate in the unit circle, again, similar idea, all right, would be root 2 over 2 and root 2 over 2 because those are the side lengths of that triangle. Okay, the other thing you got to keep in mind here is we could continue to do this the whole way around the circle. We're not going to. All right, I'm sure there's going to be lots of questions about this. This is typically a pretty hot topic in pre-calc, okay? I don't make you memorize it in trig, all right? But regardless, the nice thing about this, though, is when I look at that third one there, which is my 60, again, okay, which is we're just flipping the 30-60 on the other side, okay, which makes the short side 1/2 now. All right, and the y side, root 3 over 2, which makes this coordinate here 1/2 root 3 over 2. Okay, the nice thing about the unit circle, for those of you that have already seen it before in other classes, is that if you know the first quadrant, you know all the quadrants. Okay, again, why do you know that? Because you took Algebra 1, right? So you know that in quadrant 2, all that changes is our x values become negative. So this would be negative root 3 over 2 and positive 1/2, right? You know that, okay? It's a reflection of this point right here. Okay, and then if you reflect it to the third quadrant, then they're both negative. So negative root 3 over 2 and negative 1/2. All right, and if you go to the fourth quadrant, now the x is positive again, but the y is negative. Okay, and again, you know all this because you took Algebra 1, right? So we're just, again, taking these concepts from geometry, relating them back to Algebra 1, and to expand sort of our general knowledge about something very, very new. Okay, we'll talk about how the angles fit into that then as well, just not all today. All right, so we're just kind of laying some groundwork here. If you're utterly confused, you could just copy down what I wrote, and then we'll put it together when you come to class. All right, so here's the last few things here to finish up. Okay, just a review of SOHCAHTOA, right? That would be geometry. You learn about right triangle trig. All right, in geometry, you learn that sine is defined, okay, as opposite, okay, over hypotenuse. You learn that cosine, okay, is defined as adjacent over hypotenuse. And you learn that tangent is defined as opposite over adjacent, okay? And we're going to continue to build off those three trig ratios throughout this particular year, okay? The other piece I want you to realize here, okay, is that this all still relates right back up to that unit circle we just talked about. Okay, and you know, I'm sort of running out of space here, but in the margin of your paper, what I want you to realize is that in that first quadrant, okay, with that first angle, okay, that if I label this as theta, which is what we were talking about, that means this is the adjacent side, okay, which in Algebra 1 we know as the x side. We know that this is the opposite side, okay? In Algebra 1, we knew that is the y side, okay? So what I want you to start to realize is that when you hear cosine, okay, you're thinking the x side. And when you hear sine, you're thinking the y side. And again, we're deriving that from our knowledge of SOHCAHTOA, okay, from geometry, combined with our knowledge, all right, of the coordinate plane from Algebra 1. Okay, so in this particular problem, this is a big jump, okay? So you're going to need to access the unit circle that I shared with you, okay? Probably to answer some of these in the homework or the practice, all right, if you get that far. But in this one here in particular, 135, I'm just going to explain as if you already knew this, and then we'll answer some questions in class together. But 135 is in the second quadrant, okay? The reference for that, like we were labeling earlier, is a 45. Okay, which means if I were to label the sides, okay, of that triangle, I would have a negative root 2 and a root 2 over 2. Okay, those are from your special triangles in geometry. Okay, that means my x coordinate is negative root 2 over 2, and my y coordinate is root 2 over 2. All right, and like the diagram I just showed you, all right, cosine is always related to the x value. Okay, so the cosine of this angle, the cosine of 135 is negative root 2 over 2. Okay, and the sine of 135 is positive root 2 over 2. So the unit circle is a lot like a modern times table for you, right? In elementary school, the sooner you learned your times tables, your math facts, the easier doing, you know, some arithmetic helped. Okay, so if you memorize the unit circle, then it just skips the step of using a calculator, okay? No different than your math facts would have done. All right, what about this one here, 150? Again, that's a quadrant 2 angle. Okay, so 150 will be all the way over here in quadrant 2. All right. So just like we labeled earlier, that only leaves 30 degrees left. All right, so that will be the triangle that we're referencing. Okay, and in that triangle earlier, we said that this was root 3 over 2 and that this was 1/2. Again, those are x and y values. All right, so your x value here is negative root 3 over 2. Your y value is 1/2. Okay, when we relate that to geometry in SOHCAHTOA, that means the cosine of 150 is negative root 3 over 2. And that the sine of 150 is 1/2. Okay, and we can continue that process with all of these problems. Okay, we'll do the 120 here, one yet, and that'll be it. So 120 again is a quadrant 2 angle. They hit us with all these quadrant 2 angles, right? So 120 will be right here. All right, so again, that's your 120, but the reference that we're talking about here, like we drew earlier, would be 60. So that would be the triangle that we're referencing. Okay, and like we said with our special right triangles, the side across from the 60 is root 3 over 2. The side across from the 30 is negative 1/2. Okay, so cosine is always the x value, so the cosine of 120 equals negative 1/2. The sine of 120 equals root 3 over 2. And again, is this something you have to have memorized? Not in particular, right? Because you all have graphing calculators on your iPads, hopefully. Okay, so like sine of 120 and enter, and I get 0.8666. It doesn't look like root 3 over 2, Mr. Warner. But if I actually figure out what root 3 over 2 is, okay, I would realize that it is 0.866. Again, so this is just another way, just like your times tables, okay, to expedite the process of thinking through and solving things, okay, without always being reliant on the calculator. All right. And then there is just the bottom piece here is just decimal values for each of these. So that's just starting to get you to realize that each of these fractional values from your special right triangles in geometry have decimal values as well. And the easier that it is for you to think about what they might be, the better that this sort of gets. So that way when you do plug it into the calculator, okay, you kind of know what you're talking about. Okay, now those are probably are or are not rounded appropriately. It doesn't really matter to me. The whole idea here would be that when you type this in your calculator, you get an answer. You know if it's a root 2 over 2 or a root 3 over 2 or 1/2. Okay, so if I typed in the cosine of negative 120, okay, and I get negative 0.5, I know that that means that this is negative 1/2. Okay, if I type in the sine of negative 120, I get 0.866. Ooh, okay, then I realize that that means negative root 3 over 2. Okay, that's the idea here behind these, all right, is that we can relate these fraction values from geometry, okay, to what their decimal values are. So as we're calculating things, all right, we can then interchange them. All right, so that's a lot of information for one day. I would say that the main thing would be copy it down, and then Monday when you come in and we start working through some practices together, then we'll be able to tie these things together. So thanks for your time today.